Hi everyone! In today's video we will do another data analytics project together. In the previous data analytics project we analyzed US health data, so we looked at different genders, charges, BMIs, other factors. In this example we will look at coffee shop transaction data. So we would be able to look at sales at different time of the day, different day of the week. Then we will look at different product sales over time. If you don't know me, I'm Karina. I'm ex-finance person turned data analyst turned data scientist. So let's begin. I will be using data from kaggle.com, link in the description. As always, we are starting with importing libraries. So we will be working with pandas to read our file, Seaborn and matplotlib to visualize data. So if you don't have those libraries modules installed, you need to at first run pip install and name of the library. But I already have all these libraries installed, so we just need to import pandas as PD, import Seaborn as CNS, and import matplotlib.pyplot as PLT. Let's run it. Okay, next we will read our file using pandas. So as always, df equals pd.read underscore cell brackets. In the brackets you indicate the path to your file, and we will do df.head to see how our file looks like. Alright, this is our data set. So we have transaction ID, transaction date, transaction time. Interestingly that they are split, so we will create a new column that will combine transaction date and transaction time together as one date time. Then we have transaction quantity, store ID, store location, product ID, unit price. So you see we don't have total sales, but total sales is transaction quantity multiplied by unit price. So we will also add a new column, total sales. Also we have product category, product type, and product detail. Let's check if there are any missing values in our data. So we would say missing values equals df.isNull brackets dot sum brackets, and then we will print our missing values to see if there are any. Okay, we can see there are no missing values in our data. Let's also run df.info to see what data types or our values are. So df.info brackets, and let's run it. Okay, so our transaction date is already in a datetime format, so we don't need to do anything to it, but we need to convert our transaction time to time delta. And why we're doing it? Because we want to add transaction date and transaction time, and when you convert something to time delta you can easily add it to date time object, and we want it as one value. We will do it in two steps. First of all, we will convert our transaction time to string type. So we say df transaction time dot s type brackets string, and then already converted thing we convert to time delta. So we say df square brackets transaction time equals pandas dot to underscore time delta brackets, and then we need to say which column we want to convert to time delta. So we say in brackets df transaction time. Let's run it. We can even rerun our df.info, and now you can see that our transaction time is time delta. As I mentioned before, I also want to create a new column, total sales or sales, which will be transaction quantity multiplied by unit price. So we say df square brackets sales equals df square brackets transaction quantity multiplied by df square brackets unit price. And also let's create this new column datetime, which will combine date and a time of every transaction. So it will be df square brackets datetime equals df square brackets transaction date plus df square brackets transaction time. And also let's print after that again our head to see how our data frame looks like now. So you can see that now we have this new column sales, which is unit price multiplied by transaction quantity, and we have datetime, which is a combination of date and time. Perfect. So now we can perform some basic descriptive statistics and visualization to understand overall trends and patterns in the data. I always start with .describe to look at some key statistics in our numeric column. df.describe brackets, let's run it. Now we can see all the stats. So we can see that our average transaction quantity is 1.44 and standard deviation of it is 0.52 and maximum number of transactions 8. Average unit price of products is around $3.38 with a wide range of 80 cents up to $45. The average total transaction amount is approximately 4.69, indicating that most transactions involve small purchases. And we can see the transaction time span is starting at 6 o'clock and our last transaction at 9 o'clock. I would assume that our stores are open from 6 to 9, and that's why we see this time here. Let's group our data by store location and analyze total sales and number of transactions. So we will create a new variable called df_location equals df.groupBy, in brackets we say store location, .agg brackets, curly brackets, because we will create a dictionary, so we will say which column we aggregate in which way. So for example, sales we will aggregate as a sum, and transaction ID we will aggregate as count. And let's print df location. Okay, so we can see that we have 3 store locations, so Astoria, Hell's Kitchen, Low on Manhattan. We can see that Hell's Kitchen has the most sales, followed by Astoria and followed by Low on Manhattan. Let's visualize data. At first, we will create a line graph to display sales by location and by date. So first step will be we need to prepare our data for visualization. So we're creating a new variable called daily sales by location equals df, or name of the original data frame, dot group by brackets. In the brackets, we indicate how we're grouping by our data. We're grouping by transaction date and store location. Dot sum, we indicating how we're grouping them. We want a total of for both of those columns, and we say dot unstack brackets. And why we do unstack method? So unstack is often used after you already grouped data to transform this data into more readable, usable format. Let me show you how a variable looks like after unstacking. Let's do it. Yeah, you can see now that after unstacking, each of our column is our location. Let's see what this dot unstack does. So I created another test variable. I repeated everything from above, but I didn't add unstack. And if I print it, you can see that we have the first column is this transaction date, the store location, and then value. And you see how different table looks like when we add dot unstack. So let's plot our data. So we say daily sales by location of the variable we've just created, dot plot brackets. Then we need to select the figure size. For our visual, I'm saying 14 by 8. I'm indicating a title, daily sales by store location. Then we add in X label, Y label. I want to have legend. I want to also add grid, X ticks rotation, meaning that while our X will not be written like this, but will be on an angle of 45 degrees. Also use tight layout so it all looks prettier, and plt.show to display our visual. Okay, we can see some spikes. We can see that, for example, in January, Hell's Kitchen performed the beta, and of course we can see that in June there are some spikes for different store locations. The best part, of course, that it is upward trend, so we can see that total sales clearly increased from January to July. I recommend us to create an area plot for this data. If you are new to Python and you're still confused about data types, pandas, and matplotlib visualization, I created a masterclass. It consists of 3 parts. In the first part, I explain data types in Python and also what is Python libraries, Python modules. In the second part, I talk about pandas library, and there are 8 home tasks where you can practice your skills, and we talk about sorting, pivoting, grouping data. And in the third part of my webinar, we learn how to visualize data in matplotlib, and we talk about different types of visuals, when are they used, how to apply it with your data. So if you're interested in doing the masterclass, link in the description and in my bio. So let's create an area chart. I will start with selecting a figure, so plt.figure brackets fixed size equals 14 by 8, exactly how it was above. To create an area chart, we say plt.stackplot brackets, and then we say the name of our variable or our data frame, daily sales by location dot index, comma, daily sales by location dot t, comma, labels equals daily sales by location. So what basically we say is that x-axis values are the dates or dot index. The y-axis values are transposed sales data. That's why daily sales by location dot t means transpose. And the labels for each area are the store locations. That's why we say daily sales by location dot columns. And of course, then we add our title, label, X label, Y label, legend, grid, etc. Let's run it. And this is how stacked array chart looks like. So now you can see total sales for a specific day, and then you can see what part, for example, Astoria contributes to. You can see that Astoria sales were like this. I know some people really like a stacked array chart. I have a friend, she's the person who introduced me to these types of chart. So sometimes it's easier to read them compared to just ordinary line graph. In our example, you can see that sales are very close to each other. It's hard to analyze. You probably need to analyze just each store separately, so you need to run this daily sales for Astoria only, then for Hell's Kitchen, for Manhattan. Let's do time series analysis. Let's analyze the sales trend over time. We will look at daily, weekly, and monthly. So let's create a new variable called daily sales, and it will be df name of the original data frame dot group by brackets. We're saying what we grouping by. We grouping by transaction date. And then square brackets sales, we're saying what data we want. We want sales, and we want it aggregated as a sum. That's why dot sum brackets. And then we want to reset index for this new data frame, for this new variable. So dot reset underscore index brackets. So we also want to add a new column, which is a day of the week. So it will be df square brackets day of week. This way you add a new column to your data frame equals df square brackets daytime dot dt dot day underscore name bracket. This way we extract name of the day and add it as a new column. Also, we want to create a new variable called weekly sales, similar to what we've done with daily sales. So weekly sales equals name of original data frame df dot group by, grouping by this day of week, new column we just created, square brackets sales, because we want total sales dot sum, so we're summing them, dot reindex, and here I'm saying the order of my days of the week. So I want it from Monday to Sunday, dot reset index. And similarly, we will create monthly sales. Also, monthly sales will be done in two steps. First of all, we will create a new column called months. So df square brackets months equals df square brackets daytime dot dt dot to underscore period brackets m, because we want month. And then we creating a new variable called monthly sales equals df dot group by, we grouping by months, square brackets sales dot sum reset index. And now let's print all these three variables. Okay, so we can see the first one is daily sales, transaction date, and sales by day. Then we have day of week and sales. So you can already spot that Monday is a big day. People go back to work, buy a lot of coffee. Saturday, Sunday looks quieter for our coffee places. And here we see sales by month. We saw the same trend when we created a line graph, that we had little sales in January. February was even worse, and then we had this upward trend towards end of our data. So if you needed to put together the findings, it will be something like the total daily sales vary significantly, with some days experiencing higher sales than others. Sales seem to increase toward the end of the analysis period, with daily sales consistently higher in June compared to January. If you look at weekly sales trend, sales are relatively consistent throughout as the week. Monday has the highest total sales, followed closely by Thursday, Wednesday, Friday. And we see that Saturday, Sunday have slightly lower sales. And monthly sales trend, sales have been increasing month over month from January to June. June has the highest total sales, followed by May and April. Let's create quickly a line graph to visualize our monthly sales. I guess we saw the whole trend before, but that was on a daily breakdown. Let's just visualize it by month. So to do that, we will say monthly sales dot plot, brackets, again figure size, comma, title, the title of our graph, adding X, Y label, grid, X ticks, site layout, plt.show. So the same steps as before, and that's our sales. We can see that February was a dip compared to January, and then total sales went up. So you can apply the same graph for weekly sales, monthly sales, and I just want to show you how to create different types of graphs. Let's create a bar chart to look at the sales by location on different days of the week. So we already created this day of week sales, but I also want to add extra element, location. So we will create a new variable called weekly sales. It will be weekly sales equals df.group by, we grouping by day of week, and we grouping by store location, square brackets sales, again dot sum, dot unstack. And to make sure that our days of the week are in correct order, so I will create a new variable called days order, and I just mentioned Monday, Tuesday to Sunday, similar to what we've done here. And then I do re-indexing. So in the previous example I did it all as one line. In this example I do as two different steps, so you can see that you don't need to create very complicated long line. You can do it step by step and to get to the result you want. Sometimes this way is more readable, easier to understand for other people than when you add everything to one line, grouping and sorting, dot reindexing, dot unstack, etc. So weekly sales equal weekly sales dot reindex brackets days order. So these two lines will ensure that order of your days of the week is like this. Let's print our weekly sales. Let's run it. So now we have a data set ready, and let's create a bar chart to visualize this data. So weekly sales, square brackets, another square brackets. In the first square brackets I indicate a list of our store location, Astoria, Hell's Kitchen, Lower Manhattan, dot plot. In the brackets I say what kind of plot I want to create, bar chart, figure size, and then again, as always, adding labels, title, and a legend. I repeat this from every video, that's why sometimes I skip it and go faster, because I think if you watched previous videos you might get bored, but please let me know if I need to go into details of every parameter of the graphs. So let's visualize it, and here we are. Yeah, so you can see that, for example, Hell's Kitchen performing much better, like in Tuesday, Friday, Sunday performs better than other two places, and Wednesday, Thursday, Astoria is the winner. As a next step, I recommend we will analyze sales by product. So we will group our data by product categories. So similar to what we've done before when we aggregated our data to create the df underscore location, this time we will do the same for def underscore category. So we're creating a new variable, df underscore category equals df.group by, we grouping by product category, and what we aggregating, sales we sum in, and transaction ID we want to get count. We also want to sort our values by sales from largest to smallest. That's why I say dot sort values brackets sales, ascending equals false. By default, ascending always equals true from smallest to largest. If you want a different order, you say ascending equals false. And let's see how our df category looks like. So this is the data. So we can see that our top sale is coffee, problem on Monday, and then we have tea, bakery, etc. Interesting, we have some packed chocolates, branded. I don't know what branded is. Maybe it's some cups. I don't know. So let's visualize hourly sales by product category. So at first we will extract hour from transaction time. We will create a new column, hour, similar how we've done with months and day of the week. So we say df square brackets hour equals df square brackets daytime dot dt dot hour, and then we need to create a new variable that we will use for our visualization. So hourly sales by product equals df dot group by. We group in by hour and by product category, and which column we want. We want sales dot sum, and we want to unstack it. We will create a bar chart, so we say hourly sales by product dot plot brackets. As a kind we say bar because we're creating a bar chart, stacked, we want a stacked bar chart, figure size, and a color map will be viridis this time. It's different shades of colors, more lovelier than this. Again, let's add all our titles and plt.show to see how our data looks like. Alright, it's hard to read, I just wanted to show you this stacked bar graph. Again, we know that our place is open from 6 to 9. Interesting that the most sales happen between 7 and 10 o'clock and the least at this 8 o'clock. So if you needed to put some summary, let's say that coffee has the highest total sales of 269,000, almost 270,000, followed by tea, which is 196,000, and then a bakery, which is 82,000. The lowest total sales are from a packaged chocolate, which is 4,400. Number of transactions by product category. Coffee also has the highest number of transactions, which is 58,400, followed by tea, 45,400, and bakery, almost 23,000 transactions. And the lowest number of transactions is packaged chocolate. Let's add a new column to calculate average sales per transaction. To do that, we say df category square brackets average sales equals df category sales divided by df category transaction ID. So I want to find the average sales per transaction, and let's visualize and see. So why I added this column, I've noticed that we have a lot of sales of coffee beans but a small transaction IDs. That's why I decided to add this average sales column, and you can see that average coffee price is 4.6, while coffee beans are very expensive. So we don't sell that many packs of coffee, but they're clearly expensive. Same with branded. I still don't know what the branded is. So the highest average sales per transaction are coffee beans. This is 22.87, followed by branded, which is 18.22, and the lowest average sale per transaction are flavors. Of course, it's just 1.24. So this is where we were looking at product category, but also we have another column called product type. So let's have a look at sales by product type. So similar to how we created a new variable df underscore category, this time we create a sales by product. So we create a new variable, sales by product equals df.group by brackets product type, because we want to group it by product type, and .agg for aggregate, brackets, then curly brackets. We create a dictionary, so sales will be summed in unit prices. We will find the average for unit price. Dot sort values. We sort in our values in descending order from largest to smallest. Let's look at our data. So we can see that the biggest sales is barista espresso and then brewed chai tea. The lowest sales is green beans. No one likes green beans. We can see clothing. That must be branded. We must be selling some clothing in our branded stuff. Okay, so we can see that barista espresso is the top performing product type with total sales of $91,000, and brewed chai tea and hot chocolate followed with total sales 77,000 and 72,000. The lowest total sales, green beans, 1,340. So let's create a bar chart to show product sales by product type. We will create a new variable called product sales df, and it equals df.group by. We group in by product category and product type, and what we want sales dot sum dot reset index, and let's print it and I will show you. So when we were looking at product category, I saw bakery, coffee, tea, and then when we looked at product type, I saw beans, coffee, etc. So I understood that product type is a part of product category. So we can see that, for example, bakery, it's biscotti, pastry, scones, branded is clothing and housewares, and then this is types of coffee, types of beans. This is how you can look, you see, at each category, and then these product types and their sales. So let's use actually Seaborn this time to visualize the data. So you'll say cns.barplot brackets data equals, we selecting our data, it is product sales df, so we select this data, comma, then we need to select what we use for x and y axis. We use product category for x, sales for y, and product type will be hue, and then we add in our labels, and of course to display the plot, dot type layout, so it's all close to each other, and dot show to display. Let's print it. Okay, our visual is very small. Let me add figure size and rerun it. Okay, I probably also need to move my legend. Let's move the legend to upper right. Let's rerun it. This is how actually I work. I create something, doesn't work, I keep moving, keep increasing the size, changing visuals, and then I clean up the file and present it to you. But of course there are a lot of trials and errors while I get to somewhere I'm happy with. So of course with this visual it's hard to see, so I tried to create these bar charts where we can see you know, what is the top seller in coffee, what's the top seller in flavors, etc. But because we have so many categories, it's congested, it's impossible to see. In this case, what I'm suggesting, we will create bar charts for each of those product categories separately, and I will create a loop which will create all these charts for us. Of course, you can create one bar chart and copy the syntax again and again and create a separate 6 or how many product categories we have, or we can create a loop that will go through and repeat the action and will create visuals for us. So first of all, we need to get unique product categories. So we will say categories equals product sales df square brackets product category dot unique brackets. And now we will create a loop that's create a separate bar chart for each of those categories. So to create a loop in Python, you always says for something in something. So for category in categories. So for each category in our unique categories, that's why we needed this unique category. We say plt.figure, we define in figure size, and I selected 5.5, otherwise they are too big. Category data equals product sales underscore df square brackets, and then we select our product category equals category. We use Seaborn to create a bar plot, so cns.barplot brackets, we select in which data we use this category data, and for X we use product type, for Y we use sales, and this way we will add our labels. You can see that for title we used F string, so F and then quotes, and here we say sales by product type in, and then we create in this category variable, so it will be different header for each bar plot. So of course for coffee it will say coffee, for tea it will say tea, and then our X and Y labels, X ticks to display the graphs. We use our this title layout and plt.shows. So let's run it. I think it's magic, you know, no matter how many years I work with programming, I'm a finance person who start doing programming. I still think it's fascinating that you click a button and something happens. Now we have all these bar charts. So sales by product type in bakery. As I said, you see our header will show different categories for each of the visuals. Okay, let's make our screen a bit bigger. Okay, so sales by product type, biscotti pastry scone. Scone the biggest sales. Was it? Oh, I didn't even realize. Okay. You see, I didn't even see it with when I looked at the table, so sometimes visuals so much easier to read than a simple table. Okay, and then we have, this is our branded, clothing and housewares, premium beans. As we know, no one buys green beans. So now you have bar charts for different product types and product categories. And let's create one more visual, sales per hour per location. So we already looked at hourly sales by product category, but let's also look at hourly sales for different locations. So we will create a new variable called hourly sales by location. So that will be df.group by brackets store location comma hour, and then square brackets because we want to get our sales dot sum brackets dot reset index. And let's print this one. And to visualize, again, we're starting with selecting figure size 14 by 8, and then we use Seaborn, so cns.barplot data. What data we say? We say hourly sales by location. We will use this data. For X, we use our hour. For Y axis, we use sales, and for hue, we use store location. Let's also add our labels and plt.show brackets to display the visual. And here we can see our sales. Interesting, so looks like at 6 o'clock, what we don't have? Astoria. So Astoria doesn't work at 6 o'clock, and Astoria doesn't work at 8 o'clock. Astoria works less than others. But clearly Astoria is doing a lot of sales at the 7 p.m., 6 p.m. when others are more crashing. But also you can see that by far Hell's Kitchen makes so much sales, or between 8 and 10 o'clock, and probably the winner in all the sales. So what other things you might look at? You can probably create a pie chart to visualize sales for those 3 locations, because pie charts and donut charts are not good when they're congested, when you have too many items. But since we have only 3 store location, it's a great candidate to one of those charts. You probably can look at different like transaction quantity per hour, because we looked at sales, but maybe it's transaction quantity not always means sales. You know, if our coffee beans are expensive, so maybe someone makes a lot of transactions but smaller sales, while others sell less items but more expensive. So yeah, that's it for this project. I think there are still things that you can look at, maybe group data differently, maybe it will be, you know, location and product type, product category all together. I actually didn't look at product detail column at all. I can say it's a specification of what type of product we are selling. So another visuals you can create is for the product detail, and then create one where it's a product category. Similar how we've done product category, product type, you can probably create something that has category, type, detail, and go into those details and see what's in it, on those average prices for the things, and who is the top seller, etc. Also, again, look sales by day, by hour. Overall, I think it's a great project for your data analytics portfolio. I hope you enjoyed this video. If there are any questions, please let me know, and I hope to see you next time.